We've seen previously how to find equivalent resistance for circuits that have multiple resistors, and we've also seen how to find equivalent capacitance for circuits that have multiple capacitors. We're going to do the same thing here for our inductors. And so real briefly, the idea here is going to be the same as what we saw for both resistors and capacitors, is that we have some network of inductors, and ultimately we're wanting to reduce it to a single inductor. So forgive my poor drawing, but there is our inductor, our LEQ, which we're using to represent our combination of our inductors. And so as we see here, our inductors are going to combine the same as resistors. So if we have a series connection of inductors, in this case, I've shown 3 inductors, L1, L2, and L3, we're simply going to add the 3 values together to get our equivalent inductance. So just like we saw with resistors, if we have inductors in series, the equivalent inductance is always going to be bigger than the biggest inductance that's in series. So again, our inductors combining the same as resistors means that if we have inductors in parallel, we're going to use the same equation as we did for parallel resistors. So we have the sum of the reciprocals, and then we invert that to get our equivalent inductance. So again, the important thing to note is that inductors and resistors combine in the same way, and then capacitors combine opposite to how inductors and resistors combine.